Hello guys, welcome back to our channel again. So in this video we will discuss the 18th question of Akash Leetcode challenge. So our question is number with the same consecutive difference. Now we have given two values, one is known as k and another is known as n. Now we have to find a number which contain n number of digits and their consecutive digits difference should be k. Means what I'm trying to say is I have to construct a number such that it should have 3 digits and each digit have different 7 with its consecutive numbers. For example, in this case n is equals to 3 and k is equals to 7. Now what all possible numbers we have? First of all, in this solution we got 181. Now among these both the difference is 7 and these both also the difference is 7. So this is the thing what we have to do, and we have to find out every possible number like this. So this is a very not simple, not tough, but a simple implementation of BFS. So if you want to try it now, it is a big hint that this question will be easily solved with the help of BFS traversing. Now let's see that how we will solve this question. So for solving, first of all we will take an example. In this case we will take n equals to 3 and let's take k equals to, let's take it to be 6. Now what we will do, we will assume some value at initial. Let's assume it to be 1. Now with the help of 1 we can construct a digit whose difference among all consecutive numbers should be 6. So how we can do this? Simply adding 6 to this. So basically what we will get, so what we will do, we will just try to add this k with our previous digit and do find the next digit. So in this case it is 6 and it is 1, so our next digit will be 1. Now let's do same thing with this also. So 6 plus 7, what the value is? Value is 13, but 13 cannot be there. Why? Because it is greater than 9. So let's decrease it. Let's decrease the value. So what should be the value? Value can be 1 because 7 minus 6 is 1 and the digit is satisfied, so we'll get our first digit as 171. Now let's take one more value at initial. Let's take it to be 2. So 2, now 2 plus 6, 8. And then again subtract, value will be simple. Again try for 3, 3, 9, 3. Now 4 we cannot take because 4 plus 6 is above 9 and 4 minus 6 is below 9. That's why we will not take 4. Similar case with 5 also. Let's try for 6. Now 6 plus 6 is 12, 6 minus 6 is 0. So we'll try to take this also. So 0 and 6. So this is our fourth case. Now let's take for 7. So for 7 also we got 1 7. So it's 7 1 7. And for 8 also we got 8 2 8. And for 9 we got 9 3 9. So with the help of these all we will easily traverse. First of all we will try to find out first digit. And with the help of this first digit, these all first digit, we can easily found all the possible next digits. So this is a simple implementation. So now we will try to implement it simply using BFS. You can directly do without using BFS also, but I prefer BFS because it is simple to implement. Just we have to write 2 separate codes and it will be easily implemented. Now first of all I have this is a simple function. Here I have initialized the answer which will store the variables. Now if n is equals to 1, then we have directly pushed back 0 because if n is equals to 1, then only 0 is a possible difference among the digits. Means we will call it further, but initially we will push back 0 only. Now in next what it will do, it will iterate over from I equals to 1 to all the values and it will call for every digit the BFS. Now what BFS will do, BFS will, whenever BFS will call, it will be called with some digit and we will push back that. What we will do, we will call it with next value. Suppose 1, from 1 we will call, and it will directly find the next digit and next digit and next digit till end, and it will also find all the combination which is possible with 1. How many it will be possible? Suppose 1 and k is 2 and with 1, so there are many possible combination. 1 2 1 2 0, sorry, 1 2 1 2 0, 1 2 2, sorry, 1 2 4. So these two combinations are there with simple above 1. That's why we'll consider all the possible combinations from 1, starting 1. This we will do with the help of this BFS. Now in this I am passing n minus 1, which is the value. Now n minus 1 will count the number of digits till now occurred. If it is equals to 0, then we will push back the values. Now whenever I'll iterate over a loop, then I'll decrement it. You can consider this recursion as a loop, because I understand it as a loop only because it will be a bit easy to understand. Now I have passed a k, which will be throughout constant. K is here constant, k is here constant, k is here constant. Now k here I have used this thing, this condition. Now after this I have used this I will be just for the current value, current starting value, which will be 1 or which will be 2, whatever the value will come. Now the last thing, which is answer, which will be our possible answer. Now what this is doing, this main code, we will look at this. So first of all, if this condition becomes true, now what this condition is, if the n is 3, now initially I am passing n equals to 2 because n minus 1, then two values more will be inserted, 2 and 1 suppose, and after that it will be equals to 0, so no other condition will be executed and it will be simply returned. Now it will not be simply returned, because to reach up to there we have to iterate over some values. So first of all I will calculate the last value. Now what last value will do, suppose I have traversed to 1 2. Now this last value will store this 2, so it will be easy to find the next element. So 2 plus, suppose k is 3, so k is here 1, so k can, here two possible values are there, 3 and 1. So with the help of this we can find this both by adding and by subtracting. So simply what we will do, we will call it by first of all adding, but we will check last plus k is less than equals to n or not. If this condition is true, then we will call, and if last minus k is greater than or equals to 0, then also we will call. Now this is the second side condition, that k should not be equals to 0, because if k is equals to 0, then infinite many solutions can be there. Sorry, infinite many solutions should not be there, many possible combinations are there, so that's why we will not do for this thing. Now here first of all count, multiply by 10 last plus k. This is the main thing which we have to notice, because this answer will be constant, this answer will be evaluated here in this part. N minus 1 I have told you, k I have told you, so I have to just tell this current thing that what this is doing. Now currently I have 1 2. Let's change the color. So currently I have 1 2. Now two possible numbers are there, 3 and 1. Now first of all let's check for the plus 1, so how it will be evaluated. Now currently I have 2 in the last. Now next digit can be 3, which is 2 plus 1, and it can be 2 minus 1, which is also equals to 1. So we have two possible combination. So how can I get 123 and 121? What I'll do, I'll just multiply it by 10, 0 will be added, and then I'll add this value. So what I'll get 123. Similarly in this also I'll multiply with 10 and I have added this value last minus k. So this is a very simple implementation of BFS in this question. So this is a very simple question. So this is a solution for the 18th question of August Leetcode challenge. So for more such videos, subscribe my channel, like the videos, share the videos, and if you do not got anything in the question, comment it down. I'll try to explain it over there, and if it is not possible in that part, then I'll definitely try to make a new video to make you understand that properly. So thank you guys.